So lesson 6.4, this will be A, the first video, college algebra, nonlinear systems of equations and inequalities. And I think you'll find that this isn't nearly as painful as what it says. For the most part, what we're going to be doing is we're going to be doing system of equations and solving them using elimination or substitution. All right, so first of all, what we're looking at is sometimes we're going to be looking at linear equations, sometimes they're going to be nonlinear equations. And if you remember, a linear equation is any equation that does not have an exponent on any of the variables. It also means that the variables are not multiplied, like xy equals 3 would be a nonlinear equation because x is multiplied by y rather than added or subtracted. So, first of all, what we're going to be doing is when we have one linear equation, like what I have there, and let's put a nonlinear equation above it. This is actually the equation for a circle. And because it doesn't have anything weird on there, it's the equation of a circle with the center at the origin at 0, 0. So we have two equations there. One is nonlinear, one is linear. When we have that situation, we're probably going to find that the substitution method is the best way to solve this. Now, you can use elimination if you want, but the substitution method is probably going to work best because of this having exponents and this one here not. I mean, how do you get these to be the same? You're going to have to multiply the bottom by an x squared, or an x to make this into an x squared, and the top by a -3 to get this to be a -3 to add to this +3. So anyway, it gets to be quite a hassle. So usually what we do is substitution when it comes to equations that are linear and nonlinear, and we use elimination if the equations are both nonlinear. Okay, so if we do it as if we were going to do substitution, we would solve for one of the variables here. So let's just solve for x. Alright, so x equals 4y over 3. So now, whenever we see an x in this top one, we're going to put 4 over 3y, or 4y over 3. So let's do that. 4y over 3 squared plus y squared equals 25. So notice we're just solving for y here. Okay, and we get something really nice like that. We make this a 9y over 9 in order for it to have a common denominator, which gives me a 25 over 9 y squared equals 25. Invert and multiply, or basically divide both sides by 25 over 9. That goes away. Invert and multiply, and y squared equals, our 25's cancel. It gives me 9, so y equals plus or minus 3. Okay, so once we find that, then we go back to our original problem, right there, and we plug in 3 for y, and we plug in -3. So here we get x for y is 3, x is 4. When y is -3, x is -4. So we get two answers there, +4,3, -4,3. So what does that mean? That means that if we were to graph this thing, we would get a graph with a circle around the origin, and we would get a line that cuts through here and intersects at 4, 3 and at -4, -3. So this is one of my solutions that I found. and this is the other solution that I found. Okay, so notice what happens. The solution set are where both of the graphs intersect, what they have in common with each other. And that's what we found there. All right, that's all we did. So what did they ask us to do? Solve. When they ask you to solve, they're just looking for the answers here of where they intersect. Okay, if they do not intersect, you're going to get an imaginary number. Okay, and that just means that they don't intersect at all. You've just got this random circle with a line maybe right here where there's no intersection. So, all right, so let's continue on here. All right, here's example 2. And again, we have a linear equation right there, so we're going to use substitution. Well, we already have a y equals that, so now wherever I see a y, I'm going to put that in its place. So x plus my y value equals 5. Okay, so instead of y, I'm putting 3 minus x squared. Alright, so let's see what we've got. X squared minus x plus 2 equals 0. Alright, I'm assuming you can do the Algebra 1 and put everything in the correct order and make it equal to 0. Now I've got this quadratic equation. Now, you could do two binomials. Two numbers multiplied together give me 2, added give me -1. There aren't any. Okay? So, I'm going to have to use quadratic formula. So, some people look at this and go, well, wait a minute. I could do negative x minus 2 and x plus 1, right? Because -2 plus 1 is -1. -2 times +1 is -2 and not +2. Okay, so that doesn't work. So if you were going to try that, don't. All right, let's do quadratic formula. I like to write it up here just so I have it to refer back to. And we do the work, and let's just do it here in yellow. And we get -1 plus or minus the square root of -1 squared minus 4 times 1 times 2 all over 2 times 1. Alright, so when you do this whole thing, you end up with, alright, and let me make a change here. You end up with 1/2 plus or minus the square root of 7/2 I. That I right there tells you that this is not going to cross. Alright, so let's get all this junk out of the way here. Well, let's keep our problem right here. This is our original one. Alright, so that is what our x equals. X equals that. Alright, so now we're going to have to substitute this into, well, the easiest one would be to substitute it into there. So 1/2 plus or minus, well, let's do the plus and then let's do the minus. Let's not keep them plus or minus. So let's take 1/2 plus the square root of 7/2 I plus y equals 5. Okay, so that's putting in the plus sign into this equation right here. And let's do the other one, 1/2 minus the square root of 7/2 I plus y equals 5. Okay, so let's set this all equal to y here. So we have y equals 5 minus 1/2 plus square root of 7/2 I. Okay, so I just isolated the y. I'm going to do the same thing here. Y equals 5 minus 1/2 minus the square root of 7/2 I. Okay, so there's my 2. 5 minus 1/2 would be 4.5 or 9/2. I do not like mixed numbers, so I make them in proper fractions. Y equals 9/2 minus the square root of 7/2 I. Alright, so what did I just find? I just found my two possible answers for y. Okay, and I already have my two possible answers for x. So let's go ahead and alright, so trying to move things around here, see if I can make it work. Alright, so there's my x right here that's moving around. So I'm going to put the x that I plugged in here, which would be 1/2 plus the square root of 7/2 I. Okay, this is the 1/2, this is the x I put in to get my y value there. Over here, my x was 1/2 minus the square root of 7/2 I. Okay, so there was the x that went with that. Alright, so all that, and I get for my 2 points of solutions, 1/2 plus the square root of 7/2 I. That's my x value. My y value that goes with that is that. And my other point of, well, it would be intersection if they did cross, but with that imaginary number, they don't cross. So there's my x value. There's my y value. Okay? So, obviously, complex solutions here kind of messed up. And you look at those and it's like, oh my gosh. Alright, so what the graph looks like, just so you know, is I've got a graph there, and then I've got a line that goes there. So see, they do not intersect. They do not intersect. Okay? Both have imaginary y values and x values, so they can't intersect. So anyway, that means there's no real number solutions. Okay, let's look at example 3, and we'll start that in the next video and go from there.